Hi, my name is Dobbs, and my 6-minute talk today is going to be about thermodynamic solar panels. So essentially, pretty much what we have here are just normal thermal panels, and I started researching this yesterday. And what this is actually, it's a little bit different than a thermal panel. I'm not going to lie, I started on this yesterday. So this is a thermodynamic solar panel. Found this out just because I used the keyword thermodynamic, and this came up. So this is not something I've ever seen here, and it looked like a lot of the websites that I saw actually were like Great Britain, United Kingdom, so it's something more common there. And what we have is thermal panel. So before I really start, I want to kind of explain the difference between the two. So a thermal panel uses like PV cells, so like photovoltaic cells, which takes the photons from the energy of the sun, converts that, so then the electrons from like the material on the surface become free, and that light energy becomes electrical energy, and that energy moves into the building and whatnot. This is not that at all, actually. This is pretty much what the phrase I heard was air source heat pump. Essentially, this is like a refrigerator in reverse. All these lines you see, they run Freon through them, so a refrigerant, and it goes, as it takes energy from the sun, it heats up, and then that increase in temperature goes into like the water system and increases the temperature of the water. So you get an next picture for that. Okay, it's kind of like what I was, let me go through the procedure real quick. This isn't kind of like what I said. Refrigerant enters the panel and absorbs heat from the atmosphere. So as it goes, the longer it goes, the more heat it starts to absorb, and that change in temperature, helps increase energy, and then that gas is then compressed to increase the temperature, and that goes into like your water system, increase the temperature, and add a water heater, and that kind of fuels all that, your shower and whatnot. So next question. All right, and it's got like a representation of it. Big difference though is you can kind of see right here. It doesn't need the sun. Like, since the refrigerant is so cold that it doesn't have to be sunlight, it can just be warmer weather. So like here, you go to bed, it's still like 75 degrees outside. It's still not cold at all. So this would still work like all the time. So you wouldn't just need sun in that. And then as it goes along, you kind of see it kind of change from blue to red, a little bit of purple. So as it runs, increases temperature, and that goes like your water heater or what have you. So you take the hot water and then it repumps cold water through the valve, and it just kind of cycles that refrigerant. It keeps increasing energy. Next. So this is kind of what I was talking about earlier. It's pretty much a refrigeration cycle in like reverse. That's all it really does. That's why people say it's not so much a thermal panel. It's just a heat pump. So you have your warm air in, cold air out, your evaporator, compressor, and so expansion valve. You just keep running that refrigeration cycle over and over again, and that's essentially what you get. You just take the warm air from the atmosphere, cold air into the building. And this is just kind of one more picture, just to kind of reemphasize what I was talking about. Cold to hot, so you're gonna get that change in temperature throughout. This is actually on the roof of the house, but you kind of normal regular heat source. With addition to that, increase the temperature of the water, and that goes to your shower, and whatever heating you have. And the last picture. And the biggest difference is the advantages between this and a solar panel. The solar panel, you're always going to see the same exact spot. It's going to be on a roof, normally south to southeast, facing the sun, because you want to make sure you maximize the time that the sun's over your house. Well, this doesn't have to be, because it just uses the ambient atmosphere temperature. So if you want to put this like on a wall, so maybe you don't like the look of the solar panel because they're not that good to look at, but you just put this on like the wall in your backyard, and the fence will block it off, so you can't see it, but it's still there. And the refrigerant, I want to say, was at like negative 22 Celsius, so it doesn't have to be very warm outside. You can work with like 70 degrees. I know with the UK, you're normally talking like 50 all year. That's why you see them. It seems that that's why you see them more often there, because it's just dreary You can't have a system that expects sunlight all the time because it's not a very sunny situation. And also it's interesting because it works at night, so you can say that's that's double the time that you can use. So sunlight and at night, and overall that will work more often and kind of help out more. So that's all I've got. You guys have any questions? So Phil.
So does the thermal one produce more energy?
Yeah, because it's working
Just so it's more efficient.
Yeah. Like the efficiencies are, it's not like a negligible, it's pretty negligible between two, but you consider that it's a rainy day tonight, it's still working. You don't need perfect conditions. Any other questions? Awesome.